All right, in today's video reference, we're moving on to section 6.4, which is solving and graphing compound inequalities. So we were doing multi-step inequalities, which is like multi-step equations, and this is kind of something different, which is compound inequalities. So here goes. So a compound inequality consists of two separate inequalities, and they'll be you'll either have an and compound inequality or an or compound inequality. So let's start with an and compound inequality looks like. So an and compound inequality, they intersect or overlap to form a line segment. So what you're basically going to look like when you do an and, so I would always, you could almost put it right here. An and will always give you a barbell for a graph. That's what we call these. Kind of looks like a barbell. Barbell. An or, on the other hand, so an and if you think about it, like if you're doing a pizza, right? If you wanted pepperonis and onions on the pizza, you'd have both pepperonis. And I don't know, onions would be like this. You'd have both on there. They overlap. It's pepperonis and onions. They should overlap. They should both be on there. Everything should be part of the solution. So hopefully that analogy helps a little bit. I'm actually recording a bit. Yeah, sorry. Sorry, Mrs. Boyle is going to come in. For a compound, so for an or inequality, or inequalities do not intersect or overlap. They have a space when graphed and the word or written between them. So basically an or, so I'll put it over here, an or like this would give you what's called a split. So you get something that looks like maybe this when you graph it, because they don't share anything in common. So thinking back to the pizza example, if I want pepperonis or onions, they're not going to have any. You can't have both. Like if someone said, give me a pepperoni pizza or an onions pizza, you can't have one that has pepperonis and onions on it, if that makes sense. Like you can't have that because you want either one that's just pepperonis or one that's just onions. So it gives you a split. So and they overlap gives you a barbell, or they don't overlap, it gives you a split. So when we do some examples, it might make a little bit more sense. So for the first one, if you look here, we have a graph, and but already you can tell if I kind of go over here in red, it's definitely a split. So I already know that this is going to be an or. So if you think about it, I'll use x for my variable. I'll start with over here. X is going to be less than -2 because it's an open dot, or it could be x is greater than 5. So that's how you would write that solution. Let's look at the next one, number 2. So interesting enough, with this one, we have the barbell, but one side's open for my inequality and one side is closed. So for this one, I would write, let's think about it. Maybe someone raise your hand. What would I write for this side? X is greater than or equal to -2. How about for this side? And you would write x is less than 5. Now, when it's an and, you can actually kind of combine it because they overlap. So some people will write it like this. So they put the x in the middle, like this, right? And then you start with this side. So you would write it is greater than or equal to, let me see how I do this, greater than or equal to -2. And it's also less than 5. So you could write it like this, or you could write x is, this is probably the best way to write it, less than or equal to 2. And you read it in that direction, or greater than, no, yeah, hold on, I got this backwards, my bad. So x is greater than or equal to, so it would look like this. Mrs. Costa gave me friction pen, so this would work. This is actually from Mrs. Costa, so I can erase this. So if I put the 2 on this side, it's going to be greater than or equal to 2. And then, right, and then this is less than or less than 5, so I have to switch this direction. What a great time to have a friction pen. So less than 5, like that. So a lot of ways to write an and inequality. So either 3 of these representations are correct. Let's try number 3. So for number 3, you could write it here. So it looks like it's going to be a split. So raise your hand. Is that going to be an or an and inequality? So hopefully you wrote this will be an or. So on the left side, who could write this part for me? X is less than or equal to -2. Or anybody want to write this part for me? X is greater than 5. So a little bit different than the first example. And then the last one, we have another and. Oops, gave it away. So I knew that because it was a barbell like this. Goes across here. It's a barbell like this. So I'm going to put an and here. Okay, so let's see if we can write it. See if we can write it the fancy way. So if I start with this side, like the -2, I would put the -2 here, and I know that this is, would I write greater than or equal to, or just greater than? Yeah, greater than or equal to. So I have to put the big part of the inequality, the alligator part, going to, so x is greater than or equal to -2, and then over here, if I want to do the 5, would I put less than or equal to? Yeah, I would put less than or equal to 5. And if I switched it, I could do x is greater than or equal to -2, like that, and less than or equal to 5. So that's a little tricky to write it that way. So let's actually try to solve a few and see what the graphs look like, and then we'll be good to go. So this is going to be a bit here. So the first thing we'll do with this one, actually, I'm going to end the video here. We'll solve these together, because I don't want my video not to work. So we'll solve these together.